over here. One of the days that I would have difficulty in class trying to go over with you. So I'm just going to point you to page 282 in your textbook. Here's the list of the rules of what we're doing in order to actually solve the Simplex tableau. So read through them very carefully, follow them exactly, and that's the way that you can come up with the solution for your Simplex tableau. Okay, so I got an example here that I've already worked through. Before I put my hand on it, maybe I can zoom out and let you see the whole thing, and you can look at it and take a minute, and we're going to go over it according to the rules. The first thing that we do is we set up the matrix, set up our equations or inequalities, look at our slack variables, and then we form the tableau. Okay, this next step that we're doing sounds very similar to row echelon form, and I'm looking at problem 23 on page 288 just as our first example. It sounds like we're going to use the same kind of rules that we did to go ahead and simplify this and to solve this by doing the times row reduction. But how we choose to do it, where we choose to do that with, is different because we're actually solving with slack variables this time. So for number 23, I've converted it into these equations. 1x plus 4y plus s sub 1, again, that's the first slack. There is no second slack in that equation. There's no z, and then there's a 9. 4x plus 1y, no slack 1, but a slack 2, no z, and 6. And then, of course, negative 4, negative 5, 0, 0, 1 for z, and then 0, 0 always goes in that spot. Okay, so we've done that. We've set up our tableau, and now we need to locate the pivot element. So we're looking at rule number 3. Rule number 3 says, locate the most negative entry on the bottom row. That determines your pivot column. So there's a negative 4, there's a negative 5, there's a 1. The most negative number on the bottom row is negative 5. So that means that this is my pivot column. Now, next we need to divide each entry in the last column above the line by the corresponding entry in the pivot column. Choose the smallest positive ratio. So what does that mean? That means that I need to take this 9 and divide it by the number in the pivot column, which is 4. Then I need to take this 6 and divide it by the number in the pivot column, which is 1. And I don't have to do it below the line because this is already determining. Which one of those gives me the smallest ratio? 9 divided by 4 is 2.25. 6 divided by 1 is 6. So our smallest number there is 4. Or 2.25, which means this is our pivot entry or pivot element. So what does that mean? Now let's go back to row echelon form. That means that I need to turn this into a 1 and I need to turn the rest of these into zeros. So what do I have to do to turn that into a 1? I need to take 1/4 of row 1 and put it back in row 1. And so that ends up with this column. Then what do I need to do? I need to turn the rest of these two into zeros. So I take 1 negative 1 times row 1, add it to row 2, and put it back in row 2. I take 5 times row 1, add it to row 3, and put it back in row 3. And that gives me this matrix. Okay. Am I done? It says, determine whether or not you've reached your maximum. Well, if there is a negative entry in the last row of your tableau, then you have not got a maximum yet. So looking at this problem, then I'm down here, looking on my last row. No, I still have a negative number there. I'm not done yet. So now this becomes my pivot column, and I have to go back to my division ratios again. 9/4 divided by 1/4 is 9. 15/4 divided by 15/4 is 1. Which one of those is smaller? 1 is smaller. This becomes my pivot element. Which means what? It means I have to turn that into 1 and the other two into zeros. So what do? I take 15/4 times 4/15 times row 2 and put it back in row 2. That'll give me a 1. Now what do I do from there? I need to turn this into a 0. So I take negative 1/4 times row 2, add it to row 1, and put it back in row 1. I take 11/4 times row 2, add it to row 3, and put it back in row 3. Again, these are the same kind of stuff that we did way back in chapter 2 when we were talking about solving matrices. So that's not new. All right. And then that gives me this matrix, which is not actually called a matrix anymore because this is a simplex tableau. How do well, let's see if I'm done. Okay, I'm done when the bottom row has no negatives in it. This has no negatives in it. So how can I read my answer then? Then it says on step here, determine the solutions. You determine the basic ones, and then you find the maximum value for z. So what does that mean? I have, and notice here that what I've done is I've come up with my x and y variables. You're used to x being in the top and y being on the second one, and then z and whatever. You're used to them going in order, but because this is the simplex method and we're using the simplex tableau, and the pivot element can be anywhere in this matrix, we have to come up with these variables by which column they're in, not by which row they're in. So here I know that x is equal to 1. Here I know that y is equal to 2. And here I know that z is our maximum at 14. So that's how you do that. I'm going to do another video, show you another example, and we'll keep working on this.